This is a production of Cornell University.
Welcome back to the 2026 Cornell Hemp webinar series. Whether you've been with us from the start or just joining today, we're happy to see you all as we carry the conversation forward in hemp research, production, and innovation. My name is Malin Murdoch. I'm a graduate student in the School of Integrative Plant Science here at Cornell, as well as your host for this 2026 series. Just a quick side note here, this webinar series is made possible through support from the College of Ag and Life Sciences, which funds graduate student extension assistantships to advance Cornell's land grant mission and support programs like this one. Before we begin today's session, I wanted to share a few updates from across the hemp community. So the Hemp Feed Coalition's monthly webinar series is underway. The last two recordings are now available. You can also register for their upcoming session next month. We also have UVM's fiber hemp production short course. It just launched yesterday. I still believe registration is open. And then lastly, the Lancaster Farming's Industrial Hemp podcast started back up earlier this month. So if you have additional resources, events, announcements, feel free to drop them in the chat. We're always excited to highlight what's happening across the hemp community. And a little nugget there, if you did listen to the podcast, you'd have learned that we've added another session to the series, which will happen on May 20th. So mark your calendars and stay tuned for who our invited speaker will be. And now for the best part here, stop share here. I am excited to introduce our speaker today, Dr. Catelyn Bridges, who recently joined the University of Nebraska-Lincoln as an assistant professor of biological systems engineering. As our series explores how hemp is measured across disciplines, today's session brings us into the post-harvest space and the role drying plays across the hemp value chain. So her work sits at a very critical intersection of engineering, sustainability, and product quality. We are very fortunate to have her. And with that, Dr. Bridges, let's dry into it. The Zoom room is yours.
Okay. So today, I'm just really excited to be here. I was just telling Malin and Kim that this is my first talk as being a faculty member talking about the work that I did in my dissertation. So I'm super excited to be here and start to have conversations about drying within the value chain, especially thinking about sustainable post-harvest processing in that space. And so today my talk will really be about focusing on how can we use solar drying technologies to preserve the quality of hemp flowers, and then also just touching on some extension methods that I use to also engage with the industry and producers and farmers on what post-harvest processes are they most familiar with, and how can I start to gauge my research to start to address some of those issues that are pretty prevalent. So I always like to start the conversation about who I am, where I come from. So I'm from Omaha, Nebraska, born and raised. I did my undergrad in biological systems engineering at the University of Nebraska-Lincoln, which is where I am now as a faculty member. So it's definitely full circle, a completely different side of things, but this is where I really started to grasp the idea of where research comes from. How am I in the lab? I was a McNair Scholar, which is a program that supports underrepresented minorities that want to go into graduate school. So that helped me get some hands-on research. And I did summer research programs as well that really just explored my aptitude for being in the lab and my love for being in the lab. After graduating with my bachelor's, I then ended up going to Texas A&M for my master's in bio and ag engineering, where I really researched how does post-harvest processes start to affect the quality of cottonseed specifically. So I looked at how does cottonseed go from cottonseed meal, and how does aflatoxin, the toxic kind of mycotoxins that are developed from fungi that propagate on cottonseed, how does that influence the quality at the end when it gets transformed into cottonseed meal, which is ultimately fed to cattle and dairy cattle. So if you have high aflatoxin levels, it then can be transmitted through the milk. And so here's where I really learned about physical properties of seed and how to qualify color, shape, size, and what does that mean for post-harvest manufacturing. And I looked at those quantifiable features to see how we can improve these processes. I looked at how aflatoxin contamination increased over time from cottonseed to cottonseed meal. Then I also used a novel technique that was non-thermal that was used for pre-treatment and post-treatment of cottonseed that was called atmospheric coplasma. So it's kind of the lightning in the bag, and it was used for decontamination. And it's really just a way to not only preserve the qualities, but to treat contaminated seed in that space. So this is where I first got intuition of what is post-harvest, how is that affecting, what does that look like for human health and animal health, and what does that look like in the space of agriculture? And I realized that it's just such a critical space, and so I just dove straight in. After my master's program, though, I really needed a break before I went to my PhD program. And so then I took a little wander around industry, and I got a job as a research scientist for a small garden supply company. And this company was located in Sacramento, California. And here is where I got to visit a lot of different recreational cannabis grow operations, indoor, outdoor, field operations. What I learned from that is that there was a need for post-harvest research within the cannabis space. So I didn't know where I was going kind of after my master's program, but I knew that once I got in the cannabis space, that's where I wanted to be. And it was really rooted in not only my expertise then being able to be used in the space for post-harvest, but really the social context around what cannabis and hemp is within the global scale, but also what does it look like in this regulatory murkiness within the United States in general. So, and just the history behind it just really drew me in of what it has done with communities and how does that translate now into the current day state of hemp and cannabis and what that looks like. And then I'm like, okay, it's time for me to go back to school. I see some problems, and what I know best is I know how to do some classes and I know how to do some research. So I went back and got my PhD in horticulture and agronomy from UC Davis. And here's where I really took time to know the plant, grow the plant, learn to love the plant and harvest it and use it for research purposes to really explore how does post-harvest really affect the quality of flowers. And so now I'm currently at the University of Nebraska-Lincoln, where I do post-harvest engineering research, really focused on drying and storage, quality, physical property analysis, also system level analysis using like LCAs to life cycle analysis to assess sustainability. And I really like to focus on hemp and cannabis and other emerging crops, but also my just foundational engineering background of drying and storage can be applied to other traditional crops such as corn, soybean, and wheat, which is heavily in Nebraska. And my teaching also is in the realm of this physical properties area and sustainable design for biological and agricultural systems. And so now let's get into the good stuff, right? I don't think I have to go too far into the research background, but I always just like to make sure I meet people where they're at. Generally, about cannabis sativa L, really focus on the hemp variety so I don't get dicey. You know, I'm in Nebraska, so it can get a little dicey if you say the word cannabis. So I'm really focused on the hemp varieties that are legal to grow. And so it's from the Cannabaceae family, and it has a close relative to hops, which is used for beer. It's an annual herbaceous flowering plant. It originated in Central Asia and is mostly dioecious, which means that there's a male and a female plant. And it's been criminalized for the last 7 decades. So when I think about my experience at UC Davis, coming into horticulture and agronomy, thinking about the science of farming, I don't really have any understanding of it, if I'm being honest. I don't come from a farming background. So when I started to learn about it, I'm like, okay, genetics, environment, and management practices, got it. But what the thing that they really drove home was this green revolution and the adoption of new varieties and technologies to really expand those ability to increase yield. I just always think about how cannabis and hemp kind of missed out on that huge opportunity to have research resources and time delegated to it so it can really grow in its specific field and be utilized in these various ways. And so one thing that I always like to mention too is like this huge crash that happened. So in this diagram, I just really use what the USDA hemp reports gave us, and it's really regarded around revenue, production, and the year that happened. And one thing I'd like to point out is that this year of 2022, there was a huge crash in both revenue, but also production. And so hopefully now, as we see hemp reports continuing to come out, that it's getting a little bit more stabilized in terms of production and revenue, but also it's just the name of the game when it's a new emerging crop, then being researched, being interested in, and that crash kind of happens naturally when new things are being introduced into the system. So I also just like to say that this 2022 either tainted a lot of people's views of the product itself, of the plant itself, or it just allowed the industry to get some resilience and people look past it and kind of kept within the industry. So this is something that I looked into. And so when I chose to research flower, it was really in regards to the floral production being so high and that being a need in California, which is where I kind of chose to lie. So as many of you know, hemp can be used for a variety of different uses. And I really like to focus on the post-harvest piece. And there's seeds, there's stalks, there's flowers. And so these can be created into a variety of products such as food, flour, feed, fuel, fabric, rope, all kind of things, industrial purposes. And so where I really focus on is this flower drying and extraction, and then retrieving those specialized metabolites that are crucial for the medicinal aspects of how hemp can be used outside of the recreational space. And so again, the reason why I chose floral hemp is because in 2025, it showed that in 2024 that there was a high use and growing of floral hemp. And so that's where I kind of focus my efforts. But as a faculty member, I'm starting to expand into the other areas where hemp can be utilized and how post-harvest really affects those spaces. Okay, so the overall goal of this research that I will talk about is really one is how does the impact of sustainable drying techniques affect medicinal hemp flowers by observing the changes in the quality, and also supporting this research and understanding how current post-harvest practices are being conducted through asking questions about perceptions and challenges that can be answered through using extension education methods. And so I just want to highlight that my goal was to assess all of these kind of medicinal compounds, which between cannabinoids, terpenes, and flavonoids. I won't get into all of the details of the research, but I'll definitely highlight some of the things that were pretty important to see. And so the goal of this is to really show that within these three compounds, you can have this entourage effect that's kind of been studied of if you have all three of these compounds together, it has more of a synergistic effect if these compounds are used individually to treat these certain ailments or medical conditions such as epilepsy, PTSD, appetite deficiency, when people are getting treated with chemotherapy and things of that nature. So that was kind of the target of these medicinal compounds. And so just to highlight what the post-harvest processing of hemp flowers is, and this is from literature, and I know it can vary depending on environment and conditions that are being placed and what kind of equipment people have to dry their sample. But typically in the field, a farmer is looking at a trichome color or a physical representation of what the plant looks like to be able to determine when it's the best time to harvest. So it's very anecdotal of when that trichome color goes from this translucent milky to a more yellow orange to a dark brown as the plant matures. It can indicate when harvest time is best. And actually research has showed that during this time, cannabinoids and terpenes change throughout the harvesting time, and that might be correlated to the change in color. And so then after you harvest the flowers, you can put them into its drying chamber, drying area. It can take up to 5 to 6 days, plus or minus less, depending if you have humidifiers, heaters, fans, things of that nature. If you have a controlled environment versus just a shed in that environment, ambient conditions really affect those conditions inside. It varies pretty greatly. I think I've even seen people say that it can take up to like 2 weeks to dry their flowers, depending on the amount that they're drying at a time. So this is just kind of an overview of maybe how long it could take if you have the correct conditions based on whatever mass you might have. Then you would trim. You can trim before drying takes place or after, but the goal is to take some of those non-flowering materials off of the flower to be able to really curate what the flower could be at the end. You put those then kind of dried flowers into a storage container, which then allow for those flowers to be cured. And it just really allows for that full potential of the flavor profile to develop. And then we also have the storage conditions in which temperature, humidity, and light are really affected, really affect the quality of those flowers, such as cannabinoids, terpenes, and those flavonoids. Then we think about hemp flowers being stored. It's said that it can be stored up to 1 year in proper conditions. And so I think, if I'm being honest, both curing, trimming, storage, and drying needs a lot more work to be able to really solidify what these are. But I think talking to the community and how they navigate these spaces will be very integral in understanding their anecdotal understanding and pairing that with research to be able to really highlight these specific parameters that are necessary to preserve the quality of flowers. And then after that, you have your flowers stored until you sell it to a dispensary or extraction facility or wherever else it goes. And then you can have extracts such as tinctures and gels and things of that nature, and gummies, or you can just have flowers that are being used in various different ways to consume. And so when we think about drying, it's really essential in preserving hemp, right? So the main thing that people are using currently is how are we drying, and it's really slow drying, and it's the most widely used technique. And what that looks like is a plant is hung up in an area that has dehumidifiers, fans, and it's the process of really slowly removing that water out without impacting those cannabinoids, terpenes, or flavonoids that might be present in the hemp flowers. And so when we think about slow drying, it has the high probability of maybe also having mold development based on the time it might take. Also, if the conditions are not being very regulated, it might attribute to high microbial growth. Other research has really looked into oven drying, microwave assisted drying, infrared drying, and freeze drying. And all of these have a variety of different impacts. Some can preserve the quality, some can dry faster, some can degrade the quality. I think overall, when we think about these more technical drying spaces, we always think about labor, we always think about energy consumption, and we also think about maintenance of these systems and what does it look like to be integrated into a current process that a farmer or producer might have. And when I was thinking about this research and thinking, okay, I'm a grad student, one, I'm broke. Two, I need to be resourceful in how I am thinking about this drying system that I want to integrate maybe into industry and into a process that somebody already has. I had to think about the regulatory murkiness and the cultural impact that's currently being done within the industry. And that really affects how somebody will adopt the technology. So if it's super high cost, if it doesn't show that it's going to create this big investment or return on investment, then somebody is probably really not likely to adopt it. So when I was thinking about something that I could personally afford, also something I could make, and something that could be adopted by others, it really led me to thinking about how can I strategically compete with this slow drying method that typically happens, and what does it look like for me to create something that is also highly likely to be adopted by people who are currently in the industry. And so I'll get to my solar dryer in a second, but first I want to give you all some insight to kind of the engineering behind drying. And what it looks like is drying is really a two-step process, and it involves the diffusion of moisture from the interior of a solid and to its surface. And then the other part is the surface then leaving into the air, which causes evaporation. And so what it looks like is we really, as engineers studying drying, we want to be able to predict how fast a material loses moisture. So then we can be able to control that moisture removal process while also preserving the quality of that. So if we think about this drying, it comes in these stages of, if you see my cursor, pretty much what happens is that the drying rate, which is the amount of time it takes to dry, is it gets into this equilibrium along with the temperature conditions. And this is associated with the moisture ratio, which is simply how wet the material is. So over time, you can see the moisture ratio decreases and then comes into this the lowest moisture it could actually have. But in these spaces, the water is actually changing within the material and being on the surface. So you can read this squares, these rectangles, but mostly what is happening is that the first part is that the water is being removed off the surface of the material at first. And then there's no more material left. There's no more water left on the outside, and there's only internal water within the substrate or the agricultural commodity. And then that's when moisture starts to remove a lot more slowly because it's not as freely available. It's now internal and it's harder to move. So you can think of it as like if we were all in this escape room and the door open, you can think that the water on the outside of the surface, everybody is leaving the room. So that's that the people are being removed pretty quickly, just like the water is being removed quickly off the surface. But then if you think about the few people left just within the room and there's obstacles and people got to get around it, that's what you think about the water being internal into the system. Now this internal water has to navigate through these small kind of holes and spaces to then get to the surface to then be removed on the outside. And so hopefully that makes a little bit of sense. I've never explained this to non-engineers. So hopefully that kind of concept of the removal of the surface versus the internal removal of the water is really important because the slowest process is towards the end getting removed of that water. And that's where we can really associate those internal diffusion and understanding the physics behind that to be able to remove that water quickly, efficiently, but also preserve the qualities that we're looking for in an agricultural commodity. And really overall, it's a public health concern, right? Like, so if somebody is consuming these products and there's mold on it, or there's aflatoxin, or there's anything that could be present based on these improper drying techniques, we need to be able to assess those public health concerns, but also mitigate that as consumers and farmers can have high quality hemp-derived products at the end. Okay, so now we can get into the research part of this. And really there's two aims here. And it's really to assess the efficacy of solar pallet drying to preserve the biochemical and physical properties of hemp. And then also examine the existing post-harvest practices by evaluating the needs, challenges, barriers, and perspectives of stakeholders within the hemp industry. So it's a very applied science approach, and then an extension kind of social science element to it as well. So my hypothesis initially for this aim 1 about the solar dryer was to implement a solar dryer that would expedite the drying process when it was compared to traditional methods, and also preserve the desired physical and chemical qualities within these flowers. And so there's a variety of different types of solar dryers, and where this solar dryer that I use, it lies within this indirect solar dryer system, which is a natural convection dryer, which is under a regulated solar dryer. So the really comparison is that if you have open drying or regulated drying with some type of manipulation happening, like a fan, a solar collector, things of that nature, or is it just right out in the sun, or is it lifted up in the sun as well? So these have a variety of different impacts and a variety of different uses, but where the my solar dryer comes into place, and I do want to highlight that I used the foundational approach from the Horticulture Innovation Center, which used to be at UC Davis under the USAID grant. And what it looked like, it was a solar pallet dryer that was a 4 foot by 4 foot by 2 foot custom made wood dryer. It's affordable, it's eco-friendly. I found all of the materials, kind of just, especially the pallets, just lying around. I bought the insulation. So how it looks is that there is insulation at the bottom here. On top of that insulation is a black tarp. And on top of that is, then you see these 2 pallets right here. The plastic then goes up and above the pallets to cover the pallets. So then it creates this solar collection here where the hot heat kind of starts here. And then this bin has a mesh bottom where the product lies. And then where that happens is then there's a fan on the other side. You can probably see it in this picture right here. And so that fan then pulls the hot air out, and from this kind of plastic area that the hot air is collecting, and it pulls it through the product that's lying on the mesh bottom. So I built it, I moved it out there, I put some wheels on it so I can move it myself. And so hopefully my thought was that somebody else can construct this with locally made material. It's portable and it's inexpensive to really collect. I only had a certain amount of budget as a graduate student, so I couldn't spend too much money either. So my goal was to be able to dry as much as I could based on the capacity that I could harvest the amount of plants. But this has been used in maize, peanuts, chickpeas, coffee beans, but this was the first time that it was being used in hemp flowers. So a little bit about my experiment. Pretty much it starts in the field, right? So I had to harvest the plants based on what I had in the field to have enough to be able to be associated with this downstream process of drying. So overall, the goal was to harvest from 2 different varieties. So here you can see this is my field plot. So I had 2 blocks out there, and then I was able to harvest 60 plants per cultivar that I had, which was Maverick and Auto CBG. And then I put it into 3 different treatments, which was forced air, passive air, and solar. I collected over 2 different trialing periods of August and September. So the seedlings were put out there at different times so I can harvest at different times. I had 2 blocks in the field and a total of 5 experimental units, which were just individual, pretty much colas from the flowers that were placed. 3 were placed in the drying conditions, and then after they were dried, 2 of those were then placed in storage conditions for 3 months. And so, yeah, they were just placed in brown plastic paper bags until I was able to put them immediately in the dryers afterwards. And so this is just how it kind of went. So I harvested, I put them in their drying conditions. Here you can see this is a shed that was put in that really is supposed to replicate that slow drying effect where environmental conditions could impact it in a way, but still constant enough to dry the plant. I put it in a drying chamber, which had a consistent temperature of 150 degrees Celsius. And then I put it in the solar dryer that I built. And then I assessed microbial load, drying kinetics, color, terpenes, and cannabinoids. And so these are showing the 2 different trialing periods of when I harvested. So this is the August time and this is the September time. And the biggest thing here is you can see there's temperature and there's relative humidity for both of these trialing periods. The ambient condition, the forced air, the passive air, and the solar dryer are also displayed here. And the biggest thing to really highlight is that the solar dryer really experienced a lot of changes within the temperature, but also the relative humidity. It was very moist in the evening time during this time in California, but then it was very, very hot and dry during the daytime. So experienced some extreme conditions. And so the goal was really just to see what it was like and how impacted was it by the environment, right? But it really shows me, and this research shows me that harvest time is really critical if you're using this type of solar dryer, if you don't have any other external things associated with it to maintain that relative humidity or temperature during the evening times. So pretty much higher temperatures correspond to lower relative humidity, which sped up the drying process. So the forced air condition, pretty much that 150 degrees Celsius chamber, maintain a consistent 150 degrees over time with a consistent relative humidity over time in both trials. And then also when we think about the solar dryer and the ambient conditions, you can see that it fluctuates pretty greatly within the system, with the shed not fluctuating as much over time. And so one way engineers, how we test the materials and discover how moisture loss is happening is through these pretty predictable curves. And we know the models that have been used to dry in other experiments. So we can apply those models to really understand how long it takes to actually dry something without doing a million experiments to associate with that model. So in this kind of experiment, what I looked at was 10 different thin layer drying models for these drying kinetic studies. And you can see this is that moisture. This is more complicated than the moisture ratio equation that I showed you in the beginning that just shows how moist something is. But these variables really show where at in the drying process is happening, how quickly that drying rate is happening within that specific kind of practice, if it's in the initial or the end phase, and what that looks like to be applied. So all these thin layer drying models really came from other research being used for flowers, for the microwave, for the freeze drying, all the different attributes, all the different drying techniques that's been used, but it hasn't been applied to solar drying yet. And so what this looks like is from those models, I identified the 2-term model being the most applicable in drying in modeling the drying time in both trials, specifically with the solar dryer. The other models ranked pretty high using R squared, RMSE, and SSE values. They had pretty high correlation with the things that were not as I guess, chaotic in terms of fluctuation of temperature and relative humidity. But the two-term drying model really used those exponential terms to introduce this space of what the coefficients were doing. And really what it looks like is if you see this moisture ratio has A exponential minus K1T, and then B exponential K minus K2T. And what that really means is that the coefficient A corresponds to the initial drying stage, and B correlates to the final drying stage. And then the Ks are really that rate at which moisture is being removed over time. And what this shows us is that we have moisture ratio on the y-axis, and then we have hours in time over the x-axis. And what you see is that the solar dryer took significantly longer than both the other drying systems, especially in the second trial here for both Maverick and Auto CBG. And so what it looks like is that from here, I can tell that there needs to be some additional improvements of how can we introduce either increase air velocity to accelerate surface evaporation, how can we decrease the air humidity through maybe using desiccants, or optimize the surface area by adjusting the shape and size of the flower. And then when we think about the second term, how can we improve? You can see that it kind of starts, there's an exponential decrease kind of at the beginning, and then it's a very slow drying process during the second half. And that's pretty typical of what you see. But now it makes me think of how can I then start to have higher temperatures and change that latter half of the drying with using additional treatment. So maybe I can do pre-treatments with microwave drying and then place them in the solar dryer. Or maybe I can understand how to increase the temperature of these dryers by enhancing the drying rate using solar collectors or heaters or something of that nature that can maybe capture that energy and use it in the nighttime to be more efficient of maintaining that relative humidity and temperature. And then I also looked at the total coloring changes. And the way we can do this is that we can look at different values, and really it's the LAB score. And that looks at how you can use those different areas. So the L indicates the lightness and the darkness. A is a range of negative to positive, which it means it goes from green to red. And then also B is a range of the negative to positive as well, which is from blue to yellow. And so when you combine all three of these parameters, you're able to perceive with this change of E value. So this delta E, which is correlated to how would a consumer perceive the change in color with their eye. And so pretty much what happened is that the highest values were associated with that 150 degrees Celsius, which is kind of common, right? If it's that hot and it's pretty consistent over X amount of hours, it's probably going to have the highest change in temperature. Highest change in color over time. And then also when we think about all drying methods really just related to a high change in color. So we're looking at is this dried sample versus this 0, which is the fresh. So it's the fresh minus the dried based on all of these different color changes that are happening, and all of them really affected the color, with Maverick not having as much color change versus the Auto CBG. And over here, this is pretty much Maverick in the field, which has this kind of purple hue, versus the Auto CBG, which is just kind of green in nature. Then I also looked at microbial load. And what that looks like is just taking those flowers directly from the field, putting them into some solution, and then plating them to be able to see how many microbial counts there are. And one thing that made me so sad, I should have already known because it was so moist in the evening, that you can see here that in trial 1 versus trial 2, given the different varieties, you can see that pretty much what happened is that trial 1 didn't have the same amount of microbial growth than trial 2. So those cooler, more moist conditions allow for those microbial communities to really develop over time. And I also looked at what does it look like versus dried and stored. So remember, I dried the flowers, but I also put them into storage over 3 months to see how that would be affected over time. And what we really noticed is that the solar dryer had way more microbial growth than the other drying conditions, which is pretty sad. But I think it just shows that in that evening time, that really made an impact on those microbial communities to be able to develop and then pretty much have resilience through the drying times during the day. I also looked at cannabinoids. This is a pretty busy figure. I'm still working on it so I can get it submitted to a paper. But overall, I looked at 6 different cannabinoids. It was CBD, CBN, CBC, CBG. And what I looked at, pretty much CBD really showed that there was an impact of decrease in these forced drying conditions within both different treatments and both different varieties. And so here you can see the fresh values versus the dry values versus the stored values for each of the trials, and then each of the treatment conditions that were placed. So I used GCMS to really articulate and understand the relative abundance coming from these different samples. And what it really looked like was that forced drying had the most impactful decrease or impactful, changes of what happens with cannabinoids is pretty much you have this acidic version and you have this neutral version. And when you introduce heat, it causes the conversion of acidic to neutral. And what that looks like is that if the temperature is higher, that means that there will be more neutral values that are present. So that's why it had the most effect on these stored conditions and also these dried conditions within the trials. And I also showed the same for CBG as well. Okay, so the major conclusions from here, because I'm getting close to this 40-minute mark and I want to tell you all about the extension piece too, is that pretty much for solar drying, the 2-term model really showed that it was the most suitable model based on these statistical analysis, but it also showed that a hemp producer might consider longer drying times to ensure high quality products to meet consumer preferences. And what that looks like is that there might be an associated when does that drying actually happen, and how can you maintain maybe those conditions during those cooler evenings to limit that amount of microbial growth that's happening. And going into the microbial growth, pretty much the second trial was due to the more favorable growing conditions of the plant pathogens within that system, being higher humidity, so more water available, and probably things for it to consume, such as the flowers. And higher drying temperatures and long drying times tend to increase decarboxylation of those acid cannabinoids going into those neutral cannabinoids, which causes pretty much a concern that if these are being used for medical applications, if we have things changing over time, then those dosages will not be the same as if they're being affected. So if we say that it's going to be this much CBD, but then it's dried and it changes to something else, then that increases that amount of CBD that's present based on that carboxylation that's happening within the acid and neutral varieties or cannabinoids. Okay, so quickly, now this aim 2 is really to describe the perceptions of hemp industry stakeholders and current participants regarding current post-harvest processes that significantly impacts adoption and implementation of technical innovations. And just overview, this study was really to understand the needs, challenges, barriers, and perspectives of hemp industry stakeholders. But the limitations of here is I had to go to every single state agricultural Department of Ag to find if they had a public availability of people who had hemp production licensees or grower licensees. And so that was limited to states that actually had that publicly available, or when I asked them if they were able to give me those things. So not all states are represented here. It was really focused on the people and the emails that I was able to retrieve based on the things that were available through their Department of Ag. And so I did semi-structured interviews to ask about post-harvest practices, challenges and improvements, and perspectives of those resources. It was about a 30-minute interview on Zoom, which allowed for assisted transcripts, and those interviews were then coded to make written descriptions of these main themes that were the outcomes. So I interviewed extensionists, key farmers, faculty, and also hemp research center directors. And this really gave me an idea of how could I create a survey that I could then ask the public based on these people who were very knowledgeable in the area of hemp. And they were represented in all different areas of the United States. And so that was pretty nice and a good foundation. And what I did with those interviews is that I used an in vivo method to start with the data. I took those kind of text data to then create codes. And then from those codes, I was able to create general themes that I'll briefly highlight those themes as quickly as I can. So pretty much theme one is really about market and viability and challenges that are associated with it. So it really discussed the potential for growth alongside the barriers that exist, such as skepticism from established agricultural industries and the need to understand the markets, and also develop complexities that happen when a market is actually being stabilized and being developed. So kind of those sub themes were really market potential versus current limitations, skepticism from traditional agriculture, and diverse applications within market readiness that were available. And these are just some highlighted quotes that came from those conversations. Theme two that came from here, since I'm a post-harvest girly, I just wanted to make sure I assessed what are the needs here. And it's really about their needs for research and best practices. There's challenges with processing, and there's technological needs, right? If we're just drying things in sheds, there's got to be some ways that maybe we can advance technology to ensure that the quality is being met while also having efficient drying methods. So it's really the desire to have research being able to take the risk to be able to implement some of these things that might impact the industry in a very positive area. Theme three was really the perceptions and sentiments of the stakeholder. And it's really like people have a lot of optimism and potential. And I think that's a good thing to hold on to, that I hope that we can continue to persevere throughout this space and do research that's impactful. But there's also some caution and challenges that are associated with it, that some people started, they got burned, and they don't know what to do after, or they don't know how to enter into the space without being perceived in a certain way. And then also the regulatory environment is pretty chaotic, and I will just leave that as it is. So it's very strict, it has high standards, but it's also a little bit complicated within the murkiness of the lay of land. The last theme is really about collaboration, networking, and innovation. One thing I just wasn't expecting was this, the way that the hemp industry really supports each other and really comes together to make sure people have the resources, passing along names, passing along resources, passing along, ideas, and how people have learned from their own kind of trial and error within the space. There's a really deep-rooted community and support and area of collaboration. And there's a lot of learning. There's a lot of focus on innovation with the regulatory murkiness and changes always happening. You kind of have to be intuitive, and you kind of have to be, innovative to be able to be resilient within the space. And there's a lot of collaborative research initiatives that are happening. Just being a new faculty member, I've just realized that a lot of people are really willing to explore these ideas, explore these concepts, especially within the post-harvest space, which makes me excited. So then I took all this knowledge, I created a survey, and then I put a survey out there. And what I can just skip over, this is pretty much the demographics of the survey. There was a lot of different races and ethnicities that were present. There was farmers, processors, academic researchers, and industry ancillary businesses. And the other really incorporates somebody being both a farmer and a processor. What I learned from here is that most people have experience with the flower part of the post-harvest chain, which is this drying, curing, storage, trimming, extractions piece, and less on the fiber and grain side. So this really highlights that there's some research needs that need to happen within all the spaces, especially if something is being more tried at in this floral space, but also in the fiber and grain needs a lot more time and resources to help develop those markets as well. And so I asked them to also rank their research needs. So the top rank was really exploring new market opportunities for hemp products, going all the way down to identifying the most effective post-harvest technologies, and the least being in investigating the environmental impact of post-harvest practices. So this really gives me an idea of where my research can go next. And it's really to bridge the gap of the past and current infrastructure of cannabis, and specifically with hemp. And then also integrating these social structures through interdisciplinary teams and stakeholder perspectives. So bringing in other people outside of engineering to kind of tackle some of these social structures that are associated with the plant itself. I also want to broaden these perspectives to the grain and fiber type of hemp. And then also just continue to create sustainable and accessible drying solutions for smallholder farmers and practice so they can make high quality, safe products that are consumed for both farmers and people. That is my slideshow, and hopefully I can answer some questions, and hopefully I finished in time.
Yeah, you're right on time. That's spot on.
I went through that last part pretty fast, so if y'all do have some questions, please just let me know.
Yeah, so I pulled up the Q&A panel, and maybe the strategy is I ask you the questions and you answer them.
Okay, let's do it. I don't know where my Zoom screen went. Oh, here we go. I think I found it.
Got it. Okay. All right. So the first question here we have is, what is atmospheric plasma? Believe you mentioned it in the intro in the context of cotton harvest.
Yeah. So atmospheric cold plasma is pretty much like you create these barriers, and with electricity, you're able to send electricity to form this kind of small bag kind of space, and you're able to have electricity be able to interact with the microbial communities that are developed. So it's a mixture of the gas species that are in there, and then also the electricity that are pretty much striking the microbial communities down, and without increasing temperature. It's just the main goal is that it's non-thermal, so it doesn't introduce any hot temperatures, which might change the quality of the product. So one of my goals is to try to see how that might influence hemp. We have some atmospheric cold plasma here at the University of Nebraska-Lincoln, and I can still also collaborate with my master's thesis advisor at Texas A&M to maybe research how that might affect grain and flour and those kind of qualities as well. So I'm interested. It's kind of it's like, I don't know if it's going to be adopted, but I think it could be cool if we can decontaminate things that might have high contamination based on the post-harvest processes.
And then the second question here is, are there secondary metabolites, terpenes, cannabinoids produced by any cellular structures on the hemp stalk? Is there a way to harvest them from the hemp straw?
That's a good question. And I don't think it's research. I know that there's been research on the roots, and that had the roots and the leaves, but I don't know if there's a lot done on the stalks. When I'm just in the field, I don't see too many trichomes, which is where the cannabinoids and terpenes and flavonoids are usually produced on the flower. But I do wonder if there's anything in the stalks, because it could be some good value added products if there are. But I don't know I don't know what the need would be for it to be present in the stalks. But plants do their own thing, so I'd be interested in just harvesting and seeing what's present using like the same GCMS protocols that I used before. But that's a good question. I'm gonna write that down.
Oops, I was muted there. The next question we have here is, do we see changes in minor cannabinoid or any cannabinoid concentrations post-harvest with these different types of drying methods? Yeah, this was.
Yeah, I think those smaller kind of minor outside of the CBD and CBG, there was definitely changes that happened just based on temperature alone. And I think what really was the driving factor is that those higher temperature conditions created that kind of decarboxylation, going from acids to neutral cannabinoids. And I think if I would have allowed more time to, we would eventually have saw a degradation of those after it reached the maximum conversion from acids to neutral. I think eventually it would have just been all neutral, and then it just would have started to degrade over time based on those conditions. But the same trend was shown in pretty much all those cannabinoids that I researched, which were minor and those major ones.
Yeah. What air speeds were tested?
Oh, yeah, I wasn't there yet. Air speeds were not tested, but that's something that I want to do in my current research now that I have a little bit more, coin, now that I have a little bit more flexibility, and then we can integrate it. So one of my goals, another part of the project that I didn't mention was a very controlled environmental part where I'm able to then specifically model air conditions, relative humidity, and temperature with a lot more control. So I want to implement that into my current lab and then assess those different conditions in an actually applicable drying situation in the field. So that's something I'm going to look forward to, but it's something I didn't have the capacity to do in my dissertation. That was a good question.
Yeah, the next one is also two we can offload questions just as an aside, so that way you don't have to worry about writing them down.
Okay, thank you.
What is a target moisture ratio? Seems like around 10%. Why is this important? Reduce transportation weight or prevent mold growing? Or
I think both, right? Because you can charge to transport, and if you have more water weight, then you're probably getting charged more. But also, it's definitely rooted in the microbial growth. So if you have a lower moisture ratio, that means you probably have a lower water activity, which means that microbial growth will not be in subsequent storage after it's being dried. And so that's really the goal, is to target a lower moisture ratio. One thing I'm interested in is seeing like the optimal moisture ratio that it should be, that allows for the highest amount of those secondary metabolites, but also just good flour, right? Like I feel like if you have too dry flour, I don't know how good that is based on the consumer. So I would also want to see if these different moisture ratios contribute to different consumer perceptions and how they perceive what that looks like. Because I feel like when you go into a dispensary, you can open it, you can smell it, you can like touch it a little bit. I don't know if you can touch it, but you can kind of see that if it's too dry, it might not be appealing to the consumer. So I would be interested to see what moisture ratios really align with consumer perception, and what does that look like for quality at the end too.
And then, did you notice any insect infestation during drying process, indoor versus outside grow?
No, it wasn't too many insects that were present. And I think this because the way that the dryer was is that the insects couldn't really get in unless they like navigated the tarp, navigated all the things to then get into the actual kind of box in which the flowers were in outside. So I think, and then the flowers were also in a paper black bag. So I didn't see too many infestations within the system itself, which was which I'm happy about because insects are not my thing. So I would have been scared. I would have thugged it out, but it would have been a lot.
You said I'm not an entomologist.
No, not at all.
Okay, we have some I think we may have answered this one, but just to run it by again. I know you said the air speeds were prior you, and you want to get into it. And I think we talked a bit to the moisture, but the question here is wind speed dependent at the beginning of the process versus the end of the process, and the goal moisture between then. Maybe we could just like quickly run back on that one.
So how does the airspeed change over time, and what does that look like for the moisture at the end?
Yeah, is there variation?
Okay.
Yeah, is there variation on the wind speed depending on the beginning and the end, and then kind of goal moisture throughout?
Yeah, so since the solar dryer was just really just in ambient conditions, there was a variety of wind speeds that were probably present. It wasn't consistent, and I didn't have like a anemometer to really track that wind speed over time digitally and automatically. So it was a little bit difficult. But what I did notice is that the solar dryer did not get to the same moisture content as the shed or the kind of chamber drying that had more consistent drying. So I think the solar dryer ended at like 13% moisture content versus the shed had like 11, and the control condition had like 10% moisture content. So there was definitely difference in that final value of moisture content that was seen out of those different conditions. And so, yeah, I think if I was able to control the wind speed a little bit more, or even harness the temperature in a way that made it more consistent, that would have made a difference in that final quality of moisture content.
Yeah. And before we get to the next question, we do have some applauses here for your market and stakeholder study.
Nice.
There's a
Thank
lot
you.
to dive into there. So, next question. With your creation of the solar drying machine, could you possibly paint the box black to further increase the temperature?
Oh, probably. Yeah, that would be a good idea to do it. I don't have it anymore. I just left it at UC Davis, but I can make another one. Uh, but yeah, I think that that could probably be a good implementation because what it's just attracting more heat within that box, making it a higher temperature for sure. That'd be smart.
And then the next question we have here, how do you see this being applied to large scale production and drying?
That's a good question. And that's something that I'm like exploring now. Of what does it look like to increase the either multiple solar dryers? Because I didn't even reach like a fourth of capacity with that solar dryer. So I would think that it could either be taller and then increase fans and solar panels on it to make it still pretty accessible and sustainable. But also, I would need to understand what is the largest capacity of maybe which acreage of hemp flowers are being grown, right? Because I feel like when I think now and I'm in Nebraska, the capacity, the floral drying is not compared to what's happening in corn here. So my mindset is also shifting of like, okay, what is large capacity and what is actually needed to have these sustainable drying systems, because it's going to be different within these different commodities. So I would actually have to do a little bit of research of what is maybe the largest acreage that's happening right now and what does it look like to create a larger scale solar dryer. I think it's possible, and I think it's probably been done in research for other spaces, but I have to see how that actually applies to current floral industries at the moment. That's a good question.
And then we have another one here. Would the reactive oxygen and nitrogen species produced by cold atmospheric plasma degrade cannabinoids, terpenes, and flavonoids?
That hasn't been researched yet. And that's a question that I want to ask. I think it could be cool to just see because I'm sure that there's some interaction happening, especially since all those trichomes are on the surface of the flower. I think those interactions will definitely have an impact on those on the quality and the amount of those secondary metabolites that are present. And I would also just be willing to see, does that affect the trichome structure itself? Like if it's interacting in that plasma is actually hitting the trichomes, is it breaking it off? Is it popping those trichome heads off? And what does that do to the amount of secondary metabolites that are present? I think that that could be really interesting. I did submit a grant to see, but we'll see if they fund it. So
Awesome.
that's a track that I'm on for sure.
Yes, good luck with that. And then we have three more questions before we round out here. Um, you mentioned using desiccants. What desiccants could be applied and how would you apply them?
That's a good question. I don't have the answer to that. I haven't looked too far into the desiccant realm. I just knew of people using desiccants for coffee drying at UC Davis, and I'm like, okay, maybe that can help with actually lowering that relative humidity within the system. So I don't know if it could be just like, applied as a layer somewhere within the system just to support the relative humidity to change. But I haven't really thought too further into it. It was just a suggestion that I made in my dissertation and to potentially explore that if I wasn't able to maybe make some alterations to keep the temperature kind of higher and more consistent. But that's something I can't think about and that I have people to ask if I start to implement that desiccant piece into the research for sure.
And then, do you have any knowledge or research about the importance of drying methods in influencing the dynamics of fusarium-derived toxins present in the flowers?
Oh, fusarium. No, But I also, in this space, I didn't research those mycotoxins, right? So, like, I just literally looked, is there microbial communities? If they are, I didn't dissect which ones were present. I just counted the colonies to see if there was more or less in certain conditions. But my goal is to actually implement some of those identifications of those mycotoxins within these varieties of different hemp types. And so my goal is to continue to do that. But I do know that fusarium has been found on flowers, so I would be interested to see how does drying affect those qualities of things as well.
And then last question, in which part of the cannabis plant is the phytoremediation material mainly stored?
Ooh, that's a good question. I don't think I know that.
Yeah,
Um,
did I read that right? Sorry.
like because that's like the pulling of things from the soil, right, into the plant. Yeah, that's a question I'm not really for sure about. But I know that cannabis and hemp have a high potential of like, taking heavy metals from the soil. So I don't know where those are stored and where they're relocated within the plant system. But I was interested to seeing just based on, public health concerns and what does that look like based on the condition of the soil and what does that look like at the end of the plant flowering? And does it change over time while it's being developed? And when is the best time to harvest to maybe limit the amount of uptake that could be happening? So I think that's an
Yeah,
interesting question.
I think I will try and answer if that's all right. I think it's like primarily in the roots and the leaves,
Okay.
to my knowledge. But yeah, sorry, I didn't know if I like skipping through here reading stuff wrong, but that's what I believe it to be. So, all
Nice.
right. Well, that concludes our second bit of the series. I'm so grateful to have you.
Thank you.
And yeah, we'll get these questions offloaded. I'll connect with Kim so we can get that to you. Thank you to everyone who stayed this long. Your amazing chat. I hope you have a great rest of your week and an even better weekend. Please fill out the survey for myself and for Caitlin. It's really helpful to um, the progress of the series, but then also to the progress of Caitlin as she's beginning her faculty position. So awesome. All
Thank you
right.
for having me. I appreciate it.
Yes, thank you, everyone.
This has been a production of Cornell University, on the web at cornell.edu.